Bonjour and welcome to the final energy video. This one is on energy resources and the environment. Hopefully we won't have too many distractions now by the monsters downstairs. Their uprising has been quelled for now. So final video, let's get straight into it. Energy resources. So we mentioned this right the way back in lesson 1 or video 1. We're not talking about energy stores here or energy transfers, we're just talking about resources. And a resource is a source of energy that we can use to power our lives. So obviously the vast majority of our life runs on electricity, the obvious differences being most of our transport, but we need some way of generating that electricity. There's non-renewable and there are renewable sources. So get rid of that and bring this up, and I will leave this up at the top. It is quite important. That says generating electricity, and I know it's going to be covered there. So generating electricity, generally speaking, in a power plant there are 4 stages involved in generating our electricity. The first one is heat is produced somehow. That heat is then used to turn the water in the power plant to steam. The steam becomes really hot and moves fast enough to actually turn a turbine. The turbine then turns a generator. That should be, a generator. Generator generates the electricity. So 4 stages. Heat, water into steam, steam turns a turbine, turbine generates electricity. So I'll make a start first of all with the non-renewable sources. I must say at this point I'm not really going to spend a lot of time looking at the advantages and disadvantages. Obviously, you can pause this video and have a look at them yourself. So fossil fuels are our first kind of non-renewable energy source. So, fossil fuels, coal, oil, natural gas. The easy way to think about this, they fall into this really easily. The heat is produced by burning them. You set the coal on fire, the heat turns water into steam, blah blah blah. Oil, same thing. Burn the oil, produces heat, etc. Natural gas. The natural gas is slightly different because we do, generally speaking, miss the water out with natural gas. You just heat up the air with natural gas, but it's the same basic premise. This is one word that I do want to keep on talk about because it does come up throughout. These are reliable. Now, reliable means whenever you want them, as long as we haven't run out, whenever you want them, they are there. If I want more electricity, I can just put more coal in. If I don't want less electricity, I can take the coal out or stop putting coal in. If I want electricity, the fossil fuels, assuming they've not run out, will always be there, and therefore they're considered reliable. The next one is nuclear power. Now, nuclear power is slightly different in that we don't burn anything, but a nuclear reactor uses a nuclear reaction to produce the heat. Heat turns the water to steam, steam turns a turbine, turbine generates electricity. So it's the same basic process as this, except we don't burn anything. And because we don't burn anything, there are no greenhouse gases. It's also reliable, huge amount of energy is released, but instead of making greenhouse gases, you make something which is arguably worse because it hangs around for a hell of a long time, and that's radioactive waste. Radioactive waste, if it gets into the food chain, into animals, into plants, will cause mutations, leads to cancer, and so on. I wouldn't necessarily worry too much about the safety concerns about the thing exploding, because generally speaking, the safety procedures inside a nuclear reactor mean that the risk of explosion is really small. But that comes with its own negative there. Moving on to the renewable energy resources, and you can see there are a lot that I've got there, and I haven't got all of them. I haven't got geothermal. Geothermal is when you use heat from the ground, hot rocks to heat up water. But again, you can find out about that. We've got solar power. Solar power, you have solar cells, which are the same things that are on calculators, make electricity straight away. A solar panel on a roof does not make electricity, it heats up water, and so that is used to reduce your heating bills. And then there are actually power plants in some countries that use thousands of mirrors to reflect the heat from the sun to a central point. That heat is used to turn water into steam, the steam turns a turbine, the turbine generates electricity. Again, you can read the advantages and disadvantages. Wind uses a wind turbine, which is generating electricity. The difference is, obviously, you don't heat up anything and you don't use steam. but in this case it's wind. The wind turns a turbine, the turbine generates electricity. Biomass is used in living things, so trees would be an example. You can cut down trees, burn them to produce heat, blah blah blah, you know the rest of it. You can use gases produced by bacteria digesting dead material that was once alive, hence the bio. Again, you burn that, produces heat, etc, etc. It does use a lot of space. If you're thinking about this, if you cut down one tree and stick it into a power station, it's not going to last very long. You need huge amounts of organisms to do this. It obviously also takes a long time to make. Wave power, as it seems, you have turbines, glorified turbines that are on the sea. The turbine moves them. The turbine generates electricity, or the waves move the turbines. The turbines generate electricity. Same thing for the tidal. The tide coming in and out generates the movement of the turbine. That generates electricity. The only thing I really, again, need to mention about these is these two. In fact, biomass as well, you could really say. These are reliable. You can see all of these others, wind, waves, solar, they're not reliable. It's not always sunny, especially in this country. It's not always windy. There's not always sufficient waves. Biomass, as long as you've got enough of it, is reliable. You can always generate electricity from it. Tidal, well, there's always 2 tides every day. Hydroelectric involves making a dam and having a huge amount of water behind the dam. The water moves through the dam. In the dam there's turbines. The water turns the turbines generate electricity. So again, these are all reliable energy resources. So, moving on, we're looking at the meeting demand. So, human society doesn't always need the same amount of electricity. There's fluctuations, time of day. So, for example, between 7 in the morning and 9 in the morning, you'll need more electricity. Why? Because people are getting ready to go to work. They need the kettle, they need showers, they have the TV on, etc. Between the morning and the evening, then the demand decreases because people aren't at home, people are at work. But certainly when people get home, when they're having their tea, the demand goes up. Similar kind of thing for seasons. So during the winter, obviously there will be a greater demand for electricity because you've got central heating and so on. In the summer, the demand for electricity drops. So what happens is, in order to save resources so you're not wasting energy all the time, you can switch off power stations, you can reduce their output so that you're not producing undue pollution. Now, the thing with coal, oil and nuclear power especially is they are difficult to switch on. Once you've got them going, that's brilliant, but coal requires a lot of heat before the coal is burning properly. Nuclear power needs to be going at a certain rate. So these energy resources are used to meet what we call our base levels. So the amount of electricity your country will need the majority of the time. When you get a surge in demand, for example, half-time of the World Cup final, when everybody gets up to make a cup of tea, there'll be a surge in demand. More people will want electricity. The country uses renewable energy because these are much easier to switch on, natural gas as well. So if you suddenly have a massive surge in demand, you might find that all the wind turbines get switched on and generate that extra electricity. So you have a base demand that is met by coal, oil and nuclear power, and those fluctuations, those little surges in demand here and there, are met by using extra renewable energy resources and natural gas. The last one to talk about is the impact on the environment, and this is pretty much as you would expect. It's pretty straightforward apart from the last bit. Obviously, most human activities have an impact on the environment. I'm sure all human activities impact the environment in some way. It's obviously our responsibility to try and minimise that impact. Now, fossil fuels release greenhouse gases. So greenhouse gases lead to global warming. Despite what people say, we are having an impact on that. Burning coal releases sulfur dioxide, produces acid rain, and so on. Nuclear power doesn't produce does not produce greenhouse gases, but as I've said before, arguably they produce radioactive waste, which is arguably worse. the radioactive waste hangs around for much, much longer. It's far, far more damaging in terms of the fact how it gets into food chains, it can cause cancer and so on. So that's a massive impact and something you do need to be aware of. Nuclear power is brilliant in terms of the amount of energy it produces and the fact there are no greenhouse gases, but there are also other environmental consequences. Your renewable energy resources do not produce atmospheric pollution at the source, but they probably do when they're being made. Okay, so making power, solar cells, solar panels, wind turbines, all of those require machines, resources, and that produces pollution. Once they're made, they don't contribute to global warming and so on, but actually making them does. This difficult idea is this idea about net increase in greenhouse gases. So biofuel, let's use an example of a tree. If I burn a tree and use that energy to produce electricity, I will also release greenhouse gases. But that carbon dioxide was in the air before the tree was started to grow. So the carbon dioxide that the tree releases when I burn it was actually in the air just previously in the first place. So I haven't increased the amount of carbon dioxide. Think of it in terms of money. If you lend me £5 and then I give you the £5 back at the end of the day, you've not had an increase in £5 because you gave me the £5 earlier on. It's the same thing here. If you burn a tree and it releases greenhouse gases, those greenhouse gases were in the atmosphere 20 years earlier. Contrast that to fossil fuels. Fossil fuels were alive 200 million years ago. So the carbon dioxide they took out of the atmosphere has not been in the atmosphere for the last 200 million years. And so therefore when you burn the fossil fuels, the carbon dioxide they release is effectively new, and so you do have an increase in greenhouse gases.